Mapping OCR upload into this architecture cleanly. Let's design this correctly, not hacky. What you want, Doctor uploads image or PDF to OCR to searchable notes. Correct architecture. First, upload, not Firestore. Upload file to Firebase storage / GCS. Then, Firestore stores file metadata, storage URL, status equal code pending. Second, OCR processing, server side, cloud function or background worker, reads file from storage, runs OCR, Vision API or Tesseract, produces text. Third, persist OCR result, write extracted text to Firestore, document notes, searchable fields. These write protobuf, mentable, ssTable, IndexedDB mirror on client. Fourth, client UI, listener sees status change, notes panel updates automatically, no polling, no manual refresh. Why this fits everything we discussed? Firestore, structured metadata plus text. Storage, large binary blobs. LSM3, append heavy OCR writes. IndexedDB, instant UI update. Why you're not asking the wrong question? You're actually circling this core realization. Abstractions don't disappear, they stack. Firestore, abstract storage engines, browser, abstract caching, SDK abstracts encoding, OS abstracts hardware. Your job isn't to remove abstraction, it's to know where each one lives. Does LiveKit touch Firestore protobuf for screen share? Short answer, yes, but only for permission or state, not for media. Long, precise answer, when a patient clicks share screen in your LiveKit app, two different flows happens. A. Control or metadata flow, Firestore involved. This happens first or in parallel, depending on your app logic. Examples of metadata you might store or check. Is screen sharing allowed? Who requested it? Which room? Who approved it? UI state, code screen share requested, code active share ID. That data from React code to Firestore Web SDK to protobuf hidden to Firestore server to memtable or ssTable to listen stream to Doctor to SDK decodes protobuf to JS objects to React re-render. These paths absolutely uses Firestore protobuf but only for metadata or state. Media flow, Firestore not involved. Once permission or state allows screen sharing, browser to get display media, to WebRTC track, to LiveKit SFU, to Doctor browser, to decoder, to GPU to display. No Firestore, no protobuf, no IndexedDB, no disk, just real-time packets, RTP or UDP. Key distinction, Firestore answers, should this happen? WebRTC handles make it happen. Does screen share metadata get stored before connection? Yes, if you design it that way, and you probably did. Common patterns, write a Firestore doc like open semi-curly bracket code screen share, open semi-curly bracket next line code requested by, patient 123, comma next line code status, code pending, closing semi-curly bracket, closing semi-curly bracket. Doctor's UI reacts via listener. Doctor clicks approve. App then enables WebRTC track. Firestore is used as a distributed state machine. IndexedDB, does the SDK write before calling my callback? Yes, this is subtle but important. Actual sequence but accurate. Listen, response arrives. to SDK decodes protobuf, to SDK writes documents to IndexedDB, to SDK updates in-memory cache, to SDK invokes your on-snapshot callback, to React renders. So IndexedDB is written before your callback fires. Your UI sees already cached data. That's why reload feels instant. Offline works, re-renders are fast. Is the initial batch keyed by query? Yes, exactly. IndexedDB stores documents by document ID, query results by collection path, filters, order by, limit. Think of it like query key to docref1 to array inside array docref1 comma docref2 comma docref3. This mirrors Firestore server-side indexes, but locally. Who enables listener resume or reload after network drop? The Firestore Web SDK does, not React, not browser, not Next.js. The SDK tracks stream state, detects network loss, keeps IndexedDB as source of truth, resubscribes using resume tokens. On reload, read IndexedDB, emit cache snapshot, open stream, apply deltas. You don't write this code, but it exists. Where does abstraction ends here? Let's draw the exact boundary again, this time browser side. Above the boundary, you interact with onSnapshot, JS objects, React State, IndexedDB, API indirectly. Below the boundary, you don't see protobuf decode, stream resume tokens, IndexedDB transactions, TCP transmits, OS page cache, absolute hard stop, binds handed to the browser's networking stack. Below that, kernel, NIC OS scheduling. Does SDK send cache data to callback immediately? Yes, that's why you see data even before the network shows activity or network tab shows activity. UI feels already loaded. Called reload is not equal called read. This is intentional. Is it stored in RAM or disk? Both. IndexedDB to disk persistent, SDK memory cache to RAM fast. That's why SDK Web SDK is fast, and the alt SDK OS page cache RAM very fast. So your OS in your machine also cache this. That's why it's fast. Repeated reads often hit JS memory to zero input or output or disk access. That's why now you're thinking, now I see why it's fast. Exactly. Will digging into SDK code confuse you? If you jump straight into source, yes, badly. If you ask targeted questions, no, it will clarify. Good questions. Where does IndexedDB write happen? Where is resume token stored? Where is protobuf decoded? Bad questions. Explain the whole SDK. You're currently asking the good kind. Final mental model, lock this in. Firestore in your LiveKit app is a state replication with protobuf encoding, LSM3 storage, client-side IndexedDB mirror. LiveKit Media is a real-time transport system, completely bypassing Firestore. They coordinate, they do not overlap. In Chrome DevTools to application to storage, you're seeing all client-side persistent layer used by your LiveKit, Firebase, plus Next.js app. Key items visible, IndexedDB, Firebase-heartbeat-database, Firebase local storage DB, local storage, session storage, cookies, cache storage, servers, workers, optional. These are not random. Each exists for a very specific reason. Firebase Heartbeat Database, what it really is, this is not Firestore data. This is Firebase SDK telemetry metadata. Purpose, it stores when the Firebase SDK last contacted Google services, which SDK versions are active, So the admin or web admin in Firebase Auth SDK, the last time it contacted that will be shown here. Which SDK versions are active, what web SDK are used, what it is also used to send heartbeat signals to Firestore backend. Why it exists? Firebase backend wants to know, is the client alive? What SDK version? How often is it used? So it is also used for analytics to know how often the client are using or connecting to the SDK on the server or on the Firebase front end. This helps debugging, throttling, feature rollout. Key point, it does not store your app data. It does not affect LiveKit Media. It does not affect Firestore listeners. Think of it as client health metadata. Firebase local storage. Firebase local storage DB. This one matters a lot. This is the big one related to everything we discussed. Despite the name, it is IndexedDB, not local storage. What it stores, depending on which Firebase products you use, Firestore, cache documents. If you use Firestore, it will save cache documents, query results, resume tokens, target metadata, which listeners are active. Firebase auth, if used, user session, refresh tokens, auth states. How Firestore uses IndexedDB, exact flow. Let's map it one-to-one with your LiveKit app. When your app reloads, next.js page loads, then Firestore SDK initializes. It reads IndexedDB, Firebase local storage DB, and then hydrates in memory cache, and immediately emits cache snapshot, and React renders UI. That's why UI loads even before network finishes. Offline works. Reload feels instant. You observe the speed. Now you know why. Where protobuf fits in hidden but crucial. You never see protobuf files because Firestore network protocol equal protobuf. Stored format on disk equal protobuf like binary. IndexedDB stores decoded but structured binary data. The flow, Firestore server to protobuf binary stream to browser SDK to decode protobuf to JS objects to write structured data into IndexedDB to serve from memory to React. So yes, Firestore data remains protobuf originated even when cached. It's just decoded at the SDK boundary. Why IndexedDB size is tiny, 12.4 kilobytes? Your screenshot shows 12.4 kilobytes total IndexedDB usage. That tells us you're caching metadata, possibly auth state, maybe a few rooms, docs or user docs. Why not large? Because LiveKit Media is not stored here. Video or audio never touches Firestore. Firestore control plane, not media plane. Where LiveKit fits in the storage model. LiveKit does not use IndexedDB for video, audio, screen share frames, EA audio streams. LiveKit uses Firestore or Firebase only for room metadata, permissions, presence, app level state. So your architecture is Firestore, IndexedDB cache to app state plus UI to LiveKit signaling to WebRTC media direct. This separation is why your app scales. Local storage versus IndexedDB, important distinction. Local storage, small, synchronous, strings only, used for feature flags, simple preferences, legacy, Firebase state. IndexedDB, large, async, structured data, used for Firestore cache, offline queries, listener resumption. Firebase move almost everything important to IndexedDB. Who handles listener resume after refresh? What you're seeing proves this answer. The Firestore Web SDK. Mechanism: resume token stored in IndexedDB. Page reload. SDK reads resume token. Reconnect stream. Only delta sent. That's why no full refetch, no flicker, no reloading spinner. Where abstraction truly ends, final boundary. Let's draw the final hardline since you asked this many times. You control React State, Firestore queries, LiveKit room logic. Firebase SDK controls protobuf decoding, IndexedDB scheme, cache, eviction, stream resumption. Browser controls IndexedDB engine, disk I/O, memory caching. OS controls page cache, SSD/HDD access, network buffers. After that, hardware, NIC physical disk. You're standing right at the React SDK boundary. Why all this suddenly click for you? You reach a key inside, so it's stored in RAM. Now I see why it's fast. That's the moment people stop being framework users and start being system thinkers. You weren't confused, you were missing one concrete visualization. This DevTools screenshot gave you that. Final mental model, tie everything together. Firestore, protobuf base, LSM3 on server, IndexedDB mirror on client, metadata plus control plane, LiveKit, WebRTC, no disk, no Firestore for media, data plane. Next.js or React, render layer, consumes cache state, stateless UI. IndexedDB, the glue, the speed, the offline brain. So does Next.js use TypeScript? Yes, Next.js fully support TypeScript and JavaScript. What is the TypeScript file actually is? So some of your TypeScript file, such as doctor.ts, is a pure browser-side React hooks. So you have their use client, and it will runs in a browser only, and it uses Firebase Web SDK. No protobuf here directly, but it talks to systems that do use protobuf. This hook does three things only: concern, auth state, where stored, Firebase auth, technology, Firebase auth Web SDK, concern, doctor name, where stored, browser local storage, technology, plain key or value, concern, session sync, where stored, IndexedDB internal, technology, SDK manage. So this file is a front-end user state manager, not networking or protobuf file, but it sits on top of layers that do use protobuf plus gRPC, and that's what you want to understand. Where protobuf actually exists in your system, protobuf is used by Firestore database, Firestore listeners, Firestore local persistence, Firestore streaming updates, listen. Protobuf is not used by Firebase Auth Web SDK, mostly REST-JSON, local storage, this React hook, virtual Next.js routes unless you explicitly use protobuf. So when we say Firestore uses protobuf binary over HTTP/2 with gRPC streaming, that applies to not sign-in pop-up, not local storage, not React with auth state, but yes, Firestore real-time queries. So Firebase auth equal browser web SDK to HTTPS REST to JSON to Firebase auth backend. Firestore equal browser web SDK to gRPC over HTTP/2 to protobuf binary streaming to Firestore frontend to LSM3 plus memtable plus wall. Where IndexedDB fits, you now understand this. IndexedDB mirrors Firestore's query result. Here's the truth tied to your code. Your hook uses local storage, that is simple string storage. You control it, key equal doctor name underscore room. Firestore SDK uses IndexedDB. This is binary cache protobuf, stored as structured blobs, SDK rehydrates on reload, offline persistence, Listener resume pending writes buffer. So yes, when Firestore receives protobuf bytes, decode into JS objects, return to your callback, and also writes an IndexedDB entry in parallel. IndexedDB content includes query metadata, document cache, mutation queue, resume tokens, listen state, heartbeat data, where your screenshot heartbeat storage fits. Those Firebase Heartbeat and Firebase Local Storage, they exist because Firebase SDK needs device identity across reloads, back-off behavior, security context, persistence of auth credentials, optimization for quotas, health monitoring, heartbeat equal code this client is alive so infrastructure scales correctly. Analytics plus abuse prevention plus routing. Nothing you need to code. SDK manage all. Let's map exactly what happens in your sign-in flow. User click sign in as doctor. Sign in with pop-up auth, provider. Second, browser opens Google Auth pop-up. No protobuf. This is OAuth HTTPS JSON to tokens. Firebase issues ID token stored in memory. IndexedDB fallback, sometimes local storage if enabled. On state change files, your React UI updates, still no protobuf. Where protobuf finally appears in your app, when your doctor performs something like join room metadata in Firestore, write consultation notes, subscribe to patient document, listen to room participant collection, listen to prescription updates, then React component to Firestore Web SDK, then encodes request to protobuf bytes, then send via HTTP/2 stream, then uh, Firestore send to Firestore frontend, then LSM3 to mem table, to wall, to compaction, then on change to protobuf document change, then it stream back to SDK decodes to JS, UI callback runs, React renders, then IndexedDB updated, then offline ready. Yes, still protobuf even in storage because protobuf is already compact binary. Storing it binary is cheaper. LiveKit WebRTC clarification, you ask, does LiveKit touch Firestore, protobuf, and screen sharing? Answer, media path, audio, video, screen. Browser WebRTC to stun or turn to LiveKit media servers to SRTP encrypted. Streams, no Firestore involved at all, no protobuf. Metadata path, rooms, participants, roles, permissions, invites. This may touch Firestore, but LiveKit control plane not equal WebRTC media plane. So yes, Firestore protobuf for metadata only. WebRTC SRTP binary for actual video or audio. So completely separate worlds. Media never goes through Firestore, Firebase admin, Next.js API, Vercel, protobuf layer. Where does abstraction end? Here, browser, you control React, Next.js client, your hook. Firebase SDK, you do not control. Auth persistent logic, IndexedDB schema, protobuf encoding logic, gRPC streaming behavior. Firestore service, fully managed infrastructure, memtable, wall, compaction, SSD storage. LiveKit, you configure behavior, they run media plus signaling infra. Your final request, map OCR upload feature cleanly into this architecture, perfect architecture, upload flow, browser, upload to GCS or Firebase storage, then metadata record in Firestore, then protobuf stored plus index, then client listeners update, then Doctor UI reacts instantly. OCR processing, Vercel serverless triggered by upload, then reads binary, then runs OCR, then writes analysis back to Firestore, then protobuf stream updates UI. UI never waits, everything async, everything's clean. Key takeaways. Your React hook does not use protobuf, but it sits above SDK.2. Firebase auth to JSON, Firebase equal protobuf plus gRPC, IndexedDB to cache plus offline plus Resume, not same as your local storage doctor name. LiveKit uses WebRTC for media. Firestore only helps coordinate metadata. Abstraction layers, you control app code, Firebase controls protocol plus persistent magic.